This is a video for Chapter 3, Part 2, starting in Section 3.7 with dictionaries. But before I begin there, let's actually go back and review just a second what we did with sets and other types of containers. So we started with strings, and it's not technically a container, but it is a container of sorts. They're immutable, so you can't access individual characters using their index, but you can't replace them using their index. So if you wanted to just get out the first character in the string alphabet here, you would do alphabet 0, and so on. The last character here would be alphabet 25. There's 26 characters in all. You have things like concatenation and length. So concatenation means I'm just adding two strings together to make another one. This is an example of the length, and also shows you a way that you can go from one line to the other if you just have a bunch of strings together. So this is one way with this backslash. You can make a string either using the double quotes at the end of the line of characters that you want to make into the string, or the single quotes. Either one will do. The next container that we looked at were list, and these are made with brackets. These are mutable. They use these brackets to make them, so you can make them like this. They have elements in them. These are called elements instead of characters. And they can be accessed using the index the same way you could access a character in a string. So the accessibility is the same kind of method. There are lots of methods: append, pop, and remove, and there's some examples here. You probably want to look through these to see how these work. You would have seen these already if you worked through some of the labs. The average of a list I've given you here can be obtained by doing the sum of the list divided by the length of the list. And this is done if you have integers, floats, or scientific numerals in your list as elements in your list. Append adds an element, so you can append and put the element you want inside of the parentheses here. Pop removes an element at a given index. So this has a particular index. This is an ordered list. So each of the index has an actual place in it, much as you have an actual place in a string. A string can't be popped or removed or appended to because it's immutable, but a list is mutable. Remove removes the first element with a given value. So in remove here, you're going to put a value on the inside. Pop, you want to give the index on the inside. Two different functions. They kind of serve the same purpose to get rid of a particular element, but here the pop does from the index, and the remove does a particular value. There are also operations for the list, and this is a short list of ones that you'll probably want to be very familiar with by the end of the semester for sure. The next container we look at is tuples or tuples. They're immutable, so you can't change one item. Like in a string, you can't change one item. In a list, you can. That makes it mutable. But here, if we wanted to, we could reassign the entire list. So like my nums here on line 5 has 5, 12, 20. We can reassign with a completely different list of completely different types of characters. There are several methods available for tuples like this, like the sum and the length, but you can't do add or append or pop. The next kind of tuple we looked at was a name tuple, and this name tuple requires an import, much as the math import. So from collections, import name tuple. On the test, you'll be expected to remember that this import needs to be there. A name tuple is also immutable because it is a type of tuple, and it needs an import here. Printing the name tuple results in a tuple that includes the field names and assignments. So if I have a name tuple called player, then the first thing I have is the name that it's going to use when it prints it out. So note that these two don't have to be the same, but it's better to make them the same. I didn't here on purpose so that you could see that they don't have to be the same. So the name of the name tuple is player. And then for each one of these, there's a field name, a field variable, so to speak, and then it'd be assigned in each one of the players. So this has the field's name, number, position, and team. So once I've assigned some players using this name tuple code, then I'm able to print out a particular player, like here Josiah, which is one of our WUU bulldogs. Go dogs. And it's going to print out the name that I've given to this name tuple item, so the player, and then the field name and its assignment for this particular player. You can also access it with the dot methods like this. So dot name, there's no parentheses here because these aren't methods or functions. These are just attributes for that particular instance of this player object. So player up here in line 3 and 4 assigns what the name tuple is going to look like. Then you can assign individual ones to these players. So you're making an instance of this player item. And then you can pull particular values off by either printing out the entire thing or printing one attribute or field at a time, like we did here. So take a good look at this. Line 3, the player is a variable assigned a name tuple with name PLYR. Like I said, this could have been PLAYER with capital P, just like this. Typically, these are the same. That's a pretty good convention to adopt yourself. And line 8 can print out the entire instance. That's what that does. And then lines 15 through 18 can print the information in a field using the dot notation. So these are the things important to know about the name tuples. Note that you can completely reassign, like here Josiah. I could reassign this completely by saying player and changing whatever's in there like you would a string. So these are immutable, so you can reassign, but you can't actually go in and get access to any particular part of it. Sets are unordered and they have unique elements. They use braces. A dictionary is the next thing we're looking at, and it's a type of set with keys and values. So you want to really pay attention to this. The dictionary will make more sense if this makes sense to you now. So you're going to use braces, or you can use set list, or you can use set a tuple. So you could use list or tuples to set these to assign values to a particular set. You can add, pop, or remove. Adding an item just puts it in the set. Pop actually only takes out a random item. So there's no way to say get rid of this item using pop. Remove does that. So remove with quotes and parentheses will let you remove an item. Now I've run this twice so that you can see that when you run it, you don't get out unique orders of this, and the popped elements are unique. So let's take a look at this. So the first names are this, so I printed those out. See, it says print first set, first names, and then first set took the set that was first names, the list that was first names, and makes it into a set. So I'm using the set with parentheses with a list in it to make the first set. So I print the first set and I get Hermione, Harry, Ron, and Albus. I print it again in the second one and I get Hermione, Albus, Ron, and Harry, which are exactly the same 4 items in the set, 4 elements in the set, but they're in a different order. So order doesn't matter for sets. It does for list. The last set here is I'm using set and I'm putting in a tuple. You see the tuple here? And I'm using the set format to make this tuple. The familiar, I'm using the brace format. So there's 3 ways to make a set. You can make a list and make a set out of it. You can make a tuple and make a set out of it. Or you can actually just put in the braces. Those all will make a set. The pop one down here will remove. I removed cats, so it removed cats from both of these. So this has no cats in it. This has no cats in it. But the pop removes a random element from the set. So polar bear, owl, toad, and phoenix are in what happened the first time I ran this. The second time I ran it was toad, polar bear, rat, and owl. So you can see this one is missing the rat, and this one is missing the phoenix. So they're not going to be unique when you pop an element out of a set. There are several set theory operations you want to be able to perform on sets. So set.intersection takes an intersection between, that would be what they share, group of things that are in all of the sets, that are common to all of the sets. Then a union puts all the information from all the sets that are in here together. The difference actually has, this should be like a set A here, so I think there's a typo. This is a particular set that you want to see the difference from the rest of them. So it returns a set containing only elements of the set that are not found in any of the provided sets. The set up here is actually a keyword. The set here is not. So there's a typo here. Set A symmetric difference set B is all the stuff that only appears in exactly one of set A or B. So that's basically the union of A and B, these two sets, without the intersection. So I've given you an example here to look over. So set 1 is the numbers 1 through 5. Set 2 is 1 written out, 2 and 2 written out. And then set 3 is a group of ones that are kind of similar to the ones above, and we also throw in A and B. Here I've used the curly braces, which I just call braces, to make the sets, and here I've used the set notation to make the set, and you have brackets in here with a list in it. So set.union has nothing to do with any of the sets that are here. This is a keyword you see, it's a little bit more gray. So I want all the things that are in any of the ones of these sets. So I throw them all together. Sets do not have repetition. Their elements are unique. So if there's 2 1s here, and there are actually 3 of them, there's 1 in each one of these sets, there's only one that will be collected here. The order that they show up here does not have to be the order here because sets are non-ordered. So throwing them all together, we get the union. The intersection between 1 and 2, I can see the only things they share are the numbers 1 and the number 2. 1 and 2. And then the set 3 dot difference, it would be all the things that are in set 3 that aren't in any of the other ones. So here, set 3 dot difference, set 1 and set 2. So everything that's already in 1 or 2 here is going to be taken out. So the number 1 is taken out, and the word 2 is taken out. So I'm left with A and B. Those are the only things that don't appear in set 1 or set 2. The symmetric difference is taking the first set, or any set, the set that's named here. So in both the difference and the symmetric difference, you have to have a set that's named. Dot the symmetric difference of set 3, it means I want all the things that in set 1 or in set 3, but not in both. So that's basically the union of set 1 and set 3 without the intersection. So 2, 3, 4, and 5 are not in set 3. 2, A, and B are not in set 1. The last thing we talk about, well, the last container we talk about in Chapter 3 is a container called a dictionary. These are used all over Python. When you're working with big databases, they're used. It gives you an insight into how a database is set up too. So this is a really important concept. We're going to talk about these in a later chapter. So this is just a little bit of a hint, and this is all you'll do before test 3 on this. Just play with this for a few minutes so you have a preview of what's coming later. This material is not on the test. Anything before this was on the test. So the dictionary is mutable. It's a set with key and value pair. So it has methods and functions to modify. So here we have a caffeine content milligrams. The first one here, you don't have to have this one if you're going to use the braces to make a set. But if you're going to play with a set, you want to make sure you have a set, and then you can put entries into it. So oftentimes if you work in a database, you'll have some kind of set that you're putting in there, some kind of column you're trying to fill in. So you'll put an empty one in, and then you'll start populating that column. But in Python, we're making the set. Line 2 is not necessary here. We could have just started with line 3. Now I wanted to show you that if you put 2 items the same, this is set, so a set has to be unique. If you have 2 items that have the same key, this is the key and this is the value. If they have the same key, it'll only use the last one that you put in. And every time I ran this, it only used that last one, the 1200, so it ignores the other one. The next thing I want to demonstrate is this is a mutable set because I can take the key caffeine content milligrams Kit Kat bar equals 6,000. So I'm adding a new entry just by saying, okay, I want to put this caffeine content as something else. And once I have it in there, then I can also change it. So I put it in here. Caffeine content was 6,000, and then I printed it out. There it is, which is way too many milligrams of caffeine for sure. And it's like I've made a typo, so I went back and I adjusted it. So now I'm resetting it to be 6. And now you can see that only uses that 6 there. If you want to get rid of one of the key value pairs in your set, in your dictionary here, this is actually a dictionary that is comprised of a set of key value pairs. So I really should say dictionary and not set. It'd be, even though it uses the same braces, it'd be not quite wrong, but just not as good as saying dictionary here. So be careful with what you're calling these different kinds of containers. If I want to get rid of one of my key value pairs here, I can write DEL, that's a keyword, DEL, and it says delete this particular key value pair. So it completely takes that out of there, and you can see in here the key value pair involving Mr. Goodbar is no longer there. Reading through 3.7, the dictionary basics, you can see pretty much what I just went through with an example. What's important to understand is that the first part is called the key and the second part is called the value for each one of the things that you're populating a dictionary with. The key here does not have to be strings. You could have all keys for Social Security numbers and something else, maybe birth dates for the second part. So these don't have to be strings and then numbers. The challenge activity in 3.7.1 just wants you to add one more line in here that would give you another car maker that has Tesla and USA. The 3.8 lab has you do pretty much the things that we've been doing in previous labs, but it throws in the dictionary as part of the lab. So you are going to have to prompt the user for input. So you remember this looks like int input with the right parentheses and then enter the wall height, feet, just like this. So think about what that should look like. The 3.8.1 lab suggests an import math here because they want you to round some numbers up. So make sure that you're using the rounding function that you need to round these up. I think it was seal for ceiling, but you can look that back up and see what that's supposed to be. 3.9 talks about the common data types. We've already looked at int, float, and string. We have sequence types and mapping types in Python. String, list, tuple are all sequence types. Notice that set is not in here because set is not ordered. So mapping type, the only mapping type that we use in Python is the dictionary type. There's a little table here to help you understand these a little better. 3.10 has some additional practice on grade calculation, so there's a little average score on the exams there. Then there's a suggestion for how you might change that program to play with this average type a little better. When you're working with integers and floats, it's good to have an understanding of where you might see an integer versus a float. So if I was combining two integers, by adding them here, I end up with an integer. Though if I did 1 divided by 2, I might get 1/2 there. I think we have. But if we do 1 with a double backslash 2, that would give me a 0 because it would truncate it to an integer. So the division and the integer division are two different things. But if we're just adding numbers here, if we add an integer and a float, we get a float. And if we add two floats, we're going to end up with a float. You can always convert an integer to a float, and it just adds a decimal to it. But a float to an integer is going to truncate. It's going to take off any of the decimal places you have, or just drop them. If you'd prefer that, say that over truncate. We've used the int, float, and string types to convert input and output. Sometimes when we're printing, we want to do that too. But here, if I wanted to convert something to an int, and the something could be an int, a float, a string with integers only, I can convert to an integer. I don't know that it makes sense to convert from an int to an int, but you might want to do that. A float will take anything that it takes in, strings with integers or fractions, and you can create a float out of here. So note that the difference between these is that the string has to only be integers to convert to an int, and it could be integers or fractions to convert to a float. Anything you have, you can make into a string. So if you have your Social Security number in as a number, you can convert that to a string and have it stored as a string. Notice here the average ALS is float. We're going to add these up and divide by 3 in order to get the average, but this is casting to get just an integer printed out. This will truncate the variable average ALS, so any of the decimal places will just be dropped. On 3.11.3, we want to do some type casting. Num_ALS A and num_ALS B are both coming in as strings, and when you put your line in here, you're going to have to use the int to convert your string back into a number. Total ALS is already considered to be an integer because it has integer input here. The 3.12 lab is just a small amount of math and some formatting. So you've seen things like this already, so this should be very straightforward for you. The 3.13 lab is an exercise in inputs. So you have a couple of inputs that are coming in, and you'll have to think about how that's coming in. Notice that it's not asking you for a prompt, so no prompt is necessary here. Both needs to be integers coming in. And then you will have a formula that's here that you're going to use in order to compute the estimated monthly mortgage on the current price. 3.14 lab is an exercise in outputting as integers and as floating point numbers. And they want integers rounded, which is different than as an integer with it truncated or with the decimals dropped. So be careful when you're working through that. We've already worked with the string formatting, but I worked with this with a colon and an S in here. So this 3.15 is showing you that if you just leave it empty, you can put a string in there. That also works for list and sets, tuples, the different kinds of containers. So basically the string formatting, this with this brace in here, that'll work for pretty much any of the containers. Here they show basically the way that you can format the strings. You can put which one you want to have where. So if you had a list here that you just wanted to put in, you could tell that the first one, which would be cat, should be put first, and the 0 one, the 0 index, which would be hat, would be put second, and then the last one would be fat. You could also leave them open and these go straight down the inferred position. And then the named placements, if you have a name for each of these things and you want to replace that name, it doesn't matter which order these are in now because it's going to find shape and place it in there. So head where hat is there. So I could rearrange these. Animal equals cat doesn't have to come first. The participation activity next will show you some positional and name replacement in format statements. So you can see first, last, first, other. So first is first name, last is last name, other is Z. So you can see here I only have to put first in one time if I'm going to use it several lines in the same sentence. In one of your lab activities, you could have done this when you were working, I think, with the paint cans. I've already talked about some of the common format specification parameters. So S, D, and F is expected for the test, and this precision F. So that's like the 0.2F that we've used. So those three are expected. The exponent, the exponential notation, or the scientific notation, hexadecimal, and binary will not be expected for this test, but the others we've worked with. We've played with the referencing format values like this already, where you have one string, you have a dot format afterwards, and then you have placeholders for each thing that's in that string. So we've already worked with those. If you want to rearrange these, you don't have to actually rearrange the variables back here, or the strings or integers, whatever you're going to be putting into your placeholders. You can give an index in front of which one you want to use where. So the 0 here goes with the 3, the 2 is going to go with the $1.50, and the tacos is the 1 here will go with the 4.5. So 0, 1, 2 indexing. You can also use a named replacement, like here count, cost, and sum. So count, cost, and sum are here. They don't have to be in any particular order here either. Positional replacement, it doesn't matter which one these are in if you're going to put a position of which one you're going to be using in which placeholder. So placeholders here, variables or whatever you want to put into them here. They suggest that when you look at this, it's what you're doing on the left and the how you're doing on the right. So what you're doing, so here would be the count, and I want it to be a string. The sum, and I want it to be a float with 2 decimal places. The last activity in chapter 3 gives you some code, and I can run this code and see that I'm 60, so I put in 60, and I'm at least 21,900 days old. Whew, not a day younger. They suggest that you create a different version that calculates things a little differently. So you might work through these exercises. This is really good for helping you to practice towards the test.